we will be quizzing. We'll be quizzing on Wednesday, my dudes. Okay. When we're in pink, we'll be quizzing this week. Okay. Over 2-4 through 2-6. Over 2-4 through 2-6. 2-4 was our Venn diagrams. 2-5 was the one we just turned in and checked. Okay. That was the syllogism and attachment. 2-6 is going to be what we're doing today. Okay. So we'll be quizzing over 2-6, and we'll also be finishing up 2-7 after our quiz. Okay. So heads up on that. Now here's the thing. Okay. With this finishing up on Wednesday, that means we're going to be reviewing on Fun Sock Friday. Okay. We're doing this Fun Sock Friday, and it means we're looking at a test next Trooper Tie Tuesday. Blessing must rain on half of us forget. Okay. So just kind of heads up, keep that on our radar. Okay. Keep that on our radar. This quiz will be similar to like our other quiz that we just had last week. Okay. Where we're going to be just over those 3 sections. Shouldn't take the whole class, that kind of thing. Okay. And this goes in as a homework grade. Goes in as a homework grade as well. Okay. Does that make sense? Okay. Questions on that?
Next week we do it Tuesday.
Yeah.
It's not a problem there.
Okay.
Well,
Okay.
no, I won't be.
Okay. We'll talk about it. What? Thank you. I shared that earlier.
Sorry, I kind of forgot about
No, I forgot about too. Okay. Hey, so with proofs, this is what this chapter has been building towards so far. Okay. This chapter has been building toward this quiz up to this point. Now, how we're gonna kind of go about it. Okay. How we're gonna not how we're gonna go about it. It's been building up to this so far. We've been having everything up to this point leading up to proofs. Now, a proof is a formal argument. It's a formal argument or a formal way of saying that something is true. Okay? If you go out in the world and you try and talk to somebody and somebody says, "Hey, the sky is brown," are you gonna believe them? Probably not, right? Because that's not true. Okay? Now, if somebody were to say, like in science class like that, like, "Hey, I think the sky is really brown, but we just see it as blue," and they start explaining about stuff and it makes sense, you might be more inclined to believe them. Okay, it's still wrong, but you might be more inclined to believe them. Okay, because they went through a formal argument and explained their reasoning. That's what a proof is. It's not about something wrong though. It's saying like, "Hey, we're going to prove why the grass is green." We're going to say, "Oh, the reason behind it is the way the light reflects off," that kind of stuff. Okay. And we can talk about all of that. Or like the reason water is not wet, except for sometimes it is wet. Okay, water wet, that whole argument. Okay. The reason why is this. Okay. So typically, if you try and like go home to your parents and like, "Hey, Mom, Dad, can I go out tomorrow? Or can I do this over the weekend?" And you might come up with an argument for it. You might say, "Hey, well, last week I was really good about doing my chores," or I've been doing good about my homework lately, or I haven't gone out in a while, something like that. You're going to present an argument. You're going to say, "Hey, here's why I think I should go. Here's my statement, and then here's my explanation of that." Okay? "Hey, I've been really good at homework. I think I've been shown that I've been responsible. I think I've earned this." That kind of stuff. You're going to go through it. And you're hopefully going to get to your closing, your ending. That hey, you got to go. You got to do whatever you wanted to do. Right? And so what this is doing is this teaching us to do this with math, but it really can be applied to everywhere. Okay? So this can also just make you better at arguments. Fun fact. Okay? If you apply the same kind of logic and reasoning to this, from this proof that we're going to do, to this real life, okay, about even non-math stuff. And just saying, "Hey, we need to explain why we get there," and that can help you win arguments. Just saying. Okay. I consider myself to be pretty good at arguments. So we're going to start off with different properties of equality, because if we teach a new style of what to do and I teach it with new material, you'll all be confused. If I teach a new style of what to do and we go back to algebra to do it, we know algebra equations, okay? Go back to algebra to do it, okay, it's going to make more sense to us, okay? So we're going to do that, and then we'll transition on Wednesday into doing it with some geometry stuff. Yes, no.
So it's going to help me win arguments.
If you apply the same kind of logic that we're doing here to real life, it can help you win arguments.
I'm interested.
Okay, see? Okay. Trying to make it relevant to you, okay? You won't use the same arguments here, but you use the same kind of process saying, "Hey, we have to explain every step why we go through it," and you explain the steps well. A lot of times you can win people over as long as the reasons are good, okay? We'll talk about that. You can't have an invalid reason, because otherwise, they're not going to believe it, okay? So, properties of equality. Addition property of equality. We're saying if A is equal to B, and number A is equal to any number B. We're just saying we have a true equation. These two things are equal. Then, if we add C to both sides of the equation, we have A plus C and B plus C, it's still true. That's what the addition property equality says, is that, hey, we can add the same thing to both sides of an equation, okay? So let's start off with an equation. Kale, give me one number. Okay, so we're going to start off 2 is equal to 2. Is that true?
I mean, I guess.
Is 2 itself?
Yeah.
Yeah, 2 is 2. Okay, Colton, give me a number. 5, okay? If I take 2 and I add 5 to the left side of the equation, and I take the right side of the equation, I also add that same 5, that C, is this still true? Is 2 plus 5 the same as 2 plus 5? That's all this is saying. Saying, hey, if you have an equation, you add the same thing to both sides, it's still true. Okay? As long as we add it to both sides, it's still true. Is it still true if I only add it to one side? No, I have to add it to both. Okay?
Wait, I have a question.
Yes.
So, why would you change the variable if A equals B? Why wouldn't it just be A?
Because it could be like 3x equals 4. So 3x could be the A, 4 could be B. Does that make sense?
Yes.
That's a good question though. Yeah. Okay. Look, yeah. I want to use the other hand too. Like both hands, yeah.
So, like for the A plus C would be like 3x
Plus
equals
5
plus 4. 3x,
equals 4 plus 5.
so 3x plus 4.
So the time when we use this in algebra, for example, okay, go back to a time when you would use something like this in algebra, and saying like, hey, if we have like 3x plus 4 is equal to 8. Okay, or excuse me, let's do 3x minus 4 is equal to 8. How do we solve this equation?
You would get the x1.
Yeah, so what's our first step? We
Add 4 to 8.
add 4. Now what happens here is we have an equation that we're saying is true. 3x minus 4 is equal to 8. That's like our A is equal to B. We're adding 4 to each side. Well, what tells us that we can do that? This property tells us that we can do that and it's okay. So then that's how you end up with this. But we're only able to do this step here because this property says we can. So that's why we're able to do that. Does that make more sense? Dope, okay? Subtraction property of equality. It's going to be the same thing except for what operation now? Subtraction. Very good, Emma, okay? Now we have A equals B, so we're going to have A minus C is equal to B minus C. Okay? Why? Give me a number.
3.
Okay, cool. We're going to say 3 is equal to 3. We start off with a true equation. 3 is equal to 3, okay? Mackenzie, give me another number. 4, cool. If I take 3 minus 4, and I do that to both sides, do we still have a true equation? Is 3 minus 4 the same as 3 minus 4? Yeah, last I checked, okay, we get negative 1 on both sides. So I was saying it's still true. So we can subtract the same thing to both sides. What if we subtract different things? What if you subtract one side by 4 and one side by 5? Is that still the same? No, it has to be the same, okay? Multiplication, same thing, but with what operation now, Taylor? Boom. Okay, we have A equals B. Now we have A times C is equal to B times C. Okay? Mace, you want to give me a number? Cool. 5 is equal to 5. That's true. Okay? Colton, give me a number. I know I asked you earlier, but I asked you again. 16. Ooh, getting fancy, okay? 5 times 16 is equal to 5 times 16. If we multiply both sides with that same number, we still get it to work out. We have 80 is equal to 80, and it's fine. Okay? Would it have worked if we had 16 on one side and then we multiply the other side by 12? No, we multiply both sides by 16 for it to stay true. Okay? The last one, division property of equality, same thing, but with what operation now this time, Jessica? Division, okay? So if A is equal to B, now we have A divided by C is the same thing as B divided by C. But here's the thing, what number can't we divide by? What number can we not divide by in math?
0.
0. So we just say that C can't be 0. We just clarify that because that breaks math. We don't like it. I love breaking math. I do it every day. Okay. Clyde, give me a number.
5.
Okay. 5 is equal to 5. That's a true equation. Okay. Sam, give me a number. 5. Okay. 5 divided by 5 is that the same thing as 5 divided by 5?
Yes.
Yeah, if we divide both sides by a number, happen to be 5 on those ones because they both pick 5, okay? You get 1 is equal to 1. So if we divide both sides of an equation by 5, we're Gucci, okay? Those aren't new properties to us. They might be new in name, but we still have used them before, okay? So let's go to the bottom 4 of this, or 5 of this table, okay? Distributive property says, hey, if we have A times the sum of B plus C, then what can we do with this? What's the distributive property say? What's it mean to distribute? Times, right? We do A times B and A times C, right? So we have A times C plus, excuse me, that should be an A. I said A times C. A times B plus A times C. We take whatever's being out here and we multiply it to each of the things inside, right? We know that to be true. We've done distributing before. Okay, we've done distributing before, right?
Yeah.
And thank you, okay? Substitution property, okay? We might know this as plugging something in. Plug it in, okay, is our slang. Okay? Exactly right, okay? Hey, if A is equal to B, then we say A may be substituted or put in place of, substituted by B in any expression or equation. So that's like saying, like when in like chapter 1 we did this a lot, where you found X and then you had to plug X in to find an angle or a segment, something like that, okay? That's the same idea. You substitute it in. Once you say you know something's equal, you can substitute it in. Okay? So it's like also kind of saying, okay, if we're making desks, okay, let's say I'm making this, okay, if I find what one of these desks measures, okay, do I have to go out and measure every single desk, or can I just take this desk and use it to measure the others? I can take this desk to measure the others, right? You do that all the times in like hands-on projects, okay? If you get one thing right, a lot of times you'll just use that as your example. That's really the same thing as substitution, okay? You're saying, hey, if this is the same as the measurements, I can use this instead of the measurements. Sometimes it's easier to do. Okay? Reflexive property for any number A equals A. Is everything equal to itself?
Yeah.
Am I the same height as myself?
Yes.
Yeah. Is Braden the same height as Braden?
Yeah.
Yeah, okay.
Well, there's
Wait, why
multiple
is
Bradens in
everything
the school.
Is Braden Wilson the same height as Braden Wilson? Yeah. Is Mrs. Haswell as nice as Mrs. Haswell? Heck yeah. Most people might not be as nice as her, but she's as nice as herself, okay? Symmetric property. Saying, hey, if A is equal to B, then we're going to mirror it. B is equal to A. We can flip the equation. We know we can flip the equation, right? We know we can say, hey, if X equals 3, we can switch them around. Same thing here. That's just called the symmetric property. We're giving it a name. It's had a name all along, now we're actually saying what it is. Okay? Transitive property. Okay, this is the last property we're learning today. I know these are really fun, guys, okay? If A equals B and B equals C, does anyone know what our last equation might be? What we can glean from that, what we can learn from that? Boom, A equals C. Okay? We can skip over B and go straight from A to C. That's kind of like our law of syllogism there. It's kind of like our law of syllogism. When we had the P to Q and Q to R, we just went straight from P to R. We kind of skipped over the Q there. Here, A to B, B to C, we skip over the B, go straight from A is equal to C. Okay? Right?
Like A is with C and
Okay. We're going to continue on Recolo's before Gracie confuses herself.
I am already
Okay.
confused.
Ooh, okay. Hey, now we're getting to our actual proof. Okay, like I said, this is a formal argument where we're going to go about and say, hey, this is how we know something's true or wrong. Right, Jessica? Right, Colton? Cool beans, okay? So, and it says, hey, new! Okay? We can use the properties of quality to justify steps, okay? We know properties are true, so we can use them as arguments. You gotta use things you know are true in an argument. You can't just use things that are false in an argument. That's not gonna help you win, okay? You can't just say, hey, I think. A lot of times that won't help you win. You gotta say facts, okay? So, two column proof, it gives us just a common format that we can use to organize our proof. There's multiple ways you can do proofs, but this is usually typically the easiest easiest to learn because of how organized it is. Okay, it's organized and it's fairly straightforward as far as the process goes. Okay, so there's two columns to a proof, hence two column. The left column is going to be the statements. We're going to list the statements or the steps. Okay, so those are like the points you're making in an argument. Those are your main points. Okay, we're saying this, this, and this. Then on the right side, we have the reasons that justify each step. So you have your main point you make, you have your statement, then you have some reasons backing it. And another main point, then you have some other or more reasons backing it. It's like a paper. You have your paragraph, you have your sentence in your paragraph, then you have the rest of the paragraph explaining it. And the next paragraph, you have a new sentence, and you have the rest of the paragraph explaining it. Same kind of thing, right, Colton? Cool beans, cool beans. Okay, we're struggling today, but hey, I believe in you, okay? Okay? Well, you know that. I personally believe in you, Colton, okay? Cool beans? Okay, it's going to do wonders for you, okay? So what can be used as reasons? What things do we know to be true? Okay? We said properties. We can use properties. Okay? I'm just saying, I'm saying I believe in his ability to be able to stay awake and stay engaged today, even though it's tough for him.
I was like, what does that statement even mean? Like,
Encouraging him.
like
Lift
I
him
get
up.
it, but like,
Metaphorically, you're thinking about.
well, I mean, obviously, but like, I mean, like, just saying it. No, I know what you're saying.
Oh,
But,
abstractly though?
Like, yeah, abstractly.
Yeah, but it's not abstract anymore. We're gonna explain it.
Well, yeah, but
I
You're
feel
saying
that.
attractive?
I
What?
figuratively feel that.
You know what I mean?
Abstract.
Oh, I'm like, you're
No.
attractive. What?
Yeah. Okay. So, properties. We can use definitions. Like if you define a word, you can say, hey, well, this word means this, and so you can use that as an argument. Okay, but in math, we use definitions of like, oh, what's congruent mean? What does this mean? What's equal mean? You know, those kind of things. Those definitions. Okay. Postulates. If we think back to postulates, okay, that was like we had our segment addition postulate in chapter 1, saying, hey, you can add two parts of a segment together to get the whole thing. Okay, two parts make a whole. Okay. That was a postulate, something that we just accept as true in this, okay? And then we have our theorems. Theorems are things that are proven true. They're things that have already been proven true, okay? It's not like a theory in science, where a lot of times theories are not necessarily true yet, okay? They're trying to prove them, but they haven't been proven, okay? A theorem has already been proven, okay? That's something that's already, we know is true because of these other things. Because of a process like this, it's been proven true. Okay? So now since they've been proven true, we can use them as part of the argument. Okay. So we're going to start off, and I'm going to explain this format. Okay? We have a table here. There's one column, two columns. Hence, two-column proof. What? No way. Okay, yes. Okay? Believe it or not. We always have a starting point. You always have a starting point. That's our given. You have to have somewhere to start, otherwise you don't know where to go. Okay? So you're starting with given. Here are our three statements we're making. Okay? And we're going to put our three reasons here. The first statement is whatever you're given. You have to have a starting point here. And our reasoning is, well, we are given. How did you get that? I was given it. Okay? How did that show up? Well, I was given it. Okay? Our last statement will always be what we're trying to prove. Because here's the thing. Okay? If somebody's arguing with you, and they end up proving themselves right, do you want them to continue arguing with you? No, you get annoyed, don't you? Okay? If you're arguing with your parents and you say, like, fine, I won't go out tonight, and they keep giving reasons, are you going to be very happy about it? No, it's like, be quiet, stop, this is annoying, okay? So, once you get to what you're trying to prove, we're not going to go anymore. You don't need to. You're going to annoy people, okay? We're not doing that, okay? And then anything in between, in this case, it's only step 2. Sometimes it'll be more. Okay, will be the in-between steps of how you get there, okay? So, we have an algebraic equation. 4x minus 1 is equal to 27. Then we get to, that's what we're given. Then we have 4x is equal to 28. Well, what happened between step 1 and step 2? We added 1 to both sides, right? Okay? Because now we don't have minus 1 anymore. There's nothing there, meaning we added 1. And this 27 became 28, meaning we added 1 to both sides. What tells us that we can add 1 to both sides of the equation and it's okay? The addition property of equality. So we can just say it's the addition property. And I'd be okay with you guys even shortening that to add property or prop, okay? The addition property says, hey, you can add something to both sides of the equation, that's okay. And then, how do we go from step 2 to step 3? How do we get from here to here? How do we get from 4x equals 28 to x equals 7? We divided both sides by 4. So what property tells us we can do that?
Division.
The division property. I'd be okay with you doing div prop, okay? But I want you to say it as division property, okay? So verbally we can say division property. Writing, I'm okay with us abbreviating it as such, okay? Before you flip your page, okay? I want to talk about a tip here, okay? Here's a tip. Sometimes this part is tough for us over here to know what to do, okay? So what I can encourage you to do is sometimes it's easier to write out what math we're doing off to the side. So if you start off with 4x minus 1 is equal to 27, we can say, okay, let's just solve the equation. Oh, add 1, add 1. And then you have 4x is equal to 28. Well, here it might be a little easier for us to see we added 1 because we actually see that plus 1. Oh, addition property tells us. Because add addition. And then, oh, divide 4, divide 4. Well, here it might be easier as for us to see the actual division going on and to say division property, okay? So sometimes solving it off to the side is very helpful. We try to keep that out of the proof though, because it makes it messier. We try to keep this as clean as possible because it's easier for to present if there's not the work, if there's not like all of your scratch work, okay? But off to the side is perfectly fine. Does that make sense? Okay. When I say Gucci, you say gang. Gucci.
Gang.
Gucci.
Gang.
Okay, dope. Okay. So we're gonna go on to number 2 here. Number 2, let's flip our page. Let's flip our page, okay? Not flipping our lid, we're flipping our page, okay? And do that if we flip our lid. Okay? So we're given the variable a divided by -6
Okay.
plus 2 is equal to 5. And we're trying to prove that a is equal to -18. So our first statement, our opening argument, is what we're given. Okay, we write the same equation we're given. It's already there.
Okay.
And our reasoning, how do we get that? It was given to us. Okay, it's always going to be our first reason. 100% of the time, our first statement is going to be what's given, and our first reasoning is going to be, hey, it was given to us. That's how we got it. Okay? Our closing argument, our last one, is what we're trying to prove. A equals -18. In between are our other steps. So now we say, hey, how do you go from step 1 to step 2? What happened here?
Subtraction.
We subtracted what from both sides?
2.
2. So what property tells us we can do that?
Subtraction.
Subtraction property. And I'm going to be careful. Let's put SUBT prop. If you're going to abbreviate it, make sure we have that T on there, okay? If you don't, I'm going to count it off. What?
I'm going to put property.
Because it is a property. I think it's important that we know it's a property and we're not just subtracting or from the same side. But I think it's important to know that we're using the property there. Some teachers would actually say that you have to write the whole like subtraction property of equality. But I'm just saying, hey, let's just write the subtraction property. Some teachers are nicer than me on that. Some teachers are harder than me on that. I'm just going to cut the middle. Okay? Yeah. Yeah, we're just saying, hey, here's the reasoning we're able to do this. Yeah. Thanks. Okay, I think so. Okay. How do we go from A to let me explain. Here's why we have to have SUBT instead of SUB. Because if you just have SUB, could that also be like substitution?
Yeah.
Yeah, we don't know. Now could that be substitution?
No.
No, there's no T right after the B there, okay? So in substitution. So if we put that we know it's subtraction. So if we're going to abbreviate it, we have to be careful, okay? Now how do we go from A divided by -6 is equal to 3, A is equal to -18?
Multiplication.
We multiply, right? Both sides by what?
By 6.
-6. So we end up having the multiplication property. Saying, hey, we can multiply both sides of the equation. Questions on that one?
Nice.
Nice. Good luck.
Thank you.
Yeah, no problem. Okay, number three, okay? We're given -9 times the quantity of 2x minus 3 is equal to 63. Hey, that goes in our first statement. And our reason for that is, hey, how'd you get it? It was given to us.
Distribute.
And hold up. And then what we're trying to prove goes last. In between, we have 2 other connecting arguments, okay? Nolan, yes, what do we do as our first step to go from the step 1 to step 2?
Distributive property.
Yeah, we use a distributive property. We distribute. I'm okay with calling it dist. Okay, D-I-S-T. It's gonna be say it distributive. I'm okay with us writing it D-I-S-T. Okay. We distribute the -9 to the 2x minus 3. Okay. I want you guys to finish the last two. Okay. Steps 3, reasons 3 and 4. I want you guys to do reasons 3 and 4. Once you have that or have questions, I want you to raise your hand. Okay. So I want you to do reasons 3 and 4 on your own. Once you have it or have questions, I want you to raise your hand. Oh, the gathering. Remember, if you haven't been checked yet, raise your hand. Or if you still have questions, raise your hand. If you haven't finished yet, raise your hand as well. Okay. Kilo property to be used on number 3. Subtraction, right? We subtracted 27 from both sides to get to that step. We're saying, hey, how did you get to this step? Oh, you subtracted from both sides, so subtraction property, okay? And then raise your hand if you want to tell me how we got to step 4. What's our reasoning for 4? Okay, go ahead, Emily. Yeah, it's a division property. Very good. We divided both sides by -18. Okay? Questions on that? I want you guys to try number 4 on your own. Okay, I want you guys to try number 4 on your own. Okay, but do the same thing. Once you're done or have questions, please raise your hand. Okay, let's try number 4 on our own. Yep, we can figure it out. Yep, you want to check? Be lit. Your email starting. If you have any questions, make sure to raise your hand as well.
What? I'm supposed to do 4 and 5. Wait.
Yeah, I didn't do that.
Oh. What kind of gum is it? My mom said under my past 4 Could be a stove.
I was going through whatever. Trying to.
The leg.
Why do you say good luck?
I hope it goes well.
Like in the bathroom?
Are we gonna wish more bad luck?
I mean,
Was
that
that
would
weird?
suck. Yeah.
I mean,
I don't really know what
I want
to
to
say.
I don't want to be weird about it, so I just say it.
I mean, it looks like a 12.
Yeah, that's weird.
No. That's weird. You had keys to that.
Hey, hey.
Still dog. I don't have one, but I have bottle packs. What changed from here?
Got to be wrong.
Oh. I can't find it now.
Christine, you want to
Oh, rip.
You just haven't read it out.
Literally?
Seriously, you want to write it?
What?
I will.
Wait,
I will.
Hey,
I will.
it's over there.
I don't know.
I'll do all of it.
You just did?
Okay.
Bring my paper.
Brucey, your old house is for sale again.
Yeah, I know. Wouldn't that just be the same? No, mine is
See what
not.
happens.
You
Which one am I doing?
Just write down the properties on number 4.
that property is hard to take care of.
Uh-huh. Not that bad. Should have been in my house before my dad.
Almost, if you don't have that right stuff.
Because I remember you used to like know like everything. Like people now know all ages.
We love my dad. Oh, my dad was kind of
It's a classic dad.
Whenever I see your dad, he's always on.
he always is. Like, so he loves mowing so much that he bought us our Renault mower, like brother. So he bought 6 push mowers. And we would take a day and mow the entire house with 80 copies.
Yeah, I remember Odin telling me that.
It sucks. And like, it wasn't like, oh, come on guys, let's do this as a family. It was like, no, this is a part of your chores, you gotta do it.
I don't know if there's a way to make that sound fun, but
No.
You gotta get creative. You gotta get all the lawnmowers on, keep them on, tie them to the back of a truck, and just drive the truck around.
there you go. There you go. That's what I was saying. Okay, thank you, Colton. Hey, you wanna say it back in the mic?
Yeah, bro.
Okay, slap on the back. Okay.
Yeah, I know.
Hey, let's talk about this, okay? So the first one is subtraction property, okay? We start by subtracting 6x from both sides, right, Sam?
Yeah.
Okay. Then we go through and we add 17 to both sides, and we have our addition property, okay? Then we go through and we divide both sides by 2. And then, hey, wait, what happens between steps 4 and 5? It flips sides, right? It like switches around. What property tells us we can do that? We can flip back to the previous page and see, oh, that's our symmetric property. So we use that. Questions on that? Okay. Hey, on number 5, we have a new one we haven't gone through yet, so we'll talk about
Wouldn't
that.
it view your reflection property?
Reflection is where the same thing's equal to itself.
Oh, my
So if you get
bad.
x equals x, that'd be reflexive.
My bad.
I forgive it. Okay. And number 5, we start out with our given. And hey, what's our first step? Our given. Our first statement is our given. And our first reason is our given. Our last reason is what we're trying. Our last statement is what we're trying to prove. Okay. Now notice, has prove ever been one of our reasons?
No.
No, it's not a valid reason to say prove. No, you have to say how you got there. Okay. Okay. So hey, what was our first step though here? Our first between the first and second, we get to do. Yeah, we use our distributive property. Okay. We distribute the -7 to the x and the 2, and we distribute the 6 to the 2x and the -4. Okay. Now this next one, reason 3, is the one we haven't done yet. Okay. And it's not actually in our notes yet, but I think we know it at the same time. What happens between step 2 and step 3? We combined like terms. We took -7x and +4x, and they were on the same side of the equal sign. So we combined them into -3x. We didn't have to subtract on both sides. We didn't have to add on both sides. We just combined what was already there on the same side. Okay. So we can just say combine like terms. So Michaela's saying CLT, combine like terms. Okay. Kind of close, right? Exactly. Okay. So we can say you say BLT.
Chicken, lettuce, tomatoes.
See, I just like I like the BLT, hold the L, hold the T. Okay. So just bacon.
Chicken.
So CLT, combine like terms. Okay. I'd also be okay if you guys wanted to. You can call it simplify. You don't have to put in both. You just put one or the other.
Yeah.
But if you want to call it simplifying, that's fine too. So we're just combining like terms. We're simplifying what's there. Okay. We're not doing something to both sides. We're just doing something with the math that's already there. So then from step 3 to step 4, what's happening? What do we notice changes? Okay. Not add. We subtract what from both sides? The 12x got subtracted from both sides. So it's a subtraction property. Okay.
How did 12x get subtracted? Because when you add the 12x, you get rid of it? Wait, no, never mind.
Already called.
Alright, never mind.
Okay. Okay. So from steps 4 to 5, how do we get from step 4 to 5? Yeah, addition property, right? We add 14 to both sides. Very good. Okay. Then last step, how do we get x by itself? Division property. Very good, Mackenzie. Okay. Questions on that? Okay. Hey, let's flip the page. We have 8 examples between these 2 pages. We're not gonna do all 8.
Wait a second.
Okay? We're not gonna do all 8. Okay? We're gonna cut through quite a few of these. Yeah. What do we notice?
They're blank.
They're blank. Okay? So we have to fill in the left side ourselves now. Okay?
Oh, so we're just
Solving the equation. But we already have the outline for us. Okay? So what's gonna be our first statement? Anybody tell me what our first statement would be here?
3x plus 1 equals -14.
Very good. 3x plus 1 equals -14. That's whatever we're given. Okay? And hey, what's our first reason? How did we get this?
Given.
It was given to us. Okay? Okay. Now hey, here's where this really comes in handy. That tip I showed you earlier. Writing the equation down somewhere on a scratch paper. Okay? And 3x plus 1 equals -14. What would we do first if we were solving this? -1. Okay, so we're going to write that in there. And 3x is equal to, what's -14 minus 1? Yeah. So we're going to write this 3x minus -15 as our second statement, our second step. Now, what's helpful here is we might not know or might make mistakes if we just do this in our head. Right, so we write it out, we're probably gonna have a better likelihood of not making those mistakes. Okay. So what allowed us to get there? We subtract, so is our subtraction property. Okay. So what would you do next? 3x is equal to -15. You divide both sides by what?
3.
And x is equal to what? And that was our division property that allowed us to get there.
Well, what else more?
Okay. Hey, wait, did we already get to what we're trying to prove?
Yeah.
We have an alignment. Are we still going to keep arguing?
Yeah.
If you make your point, you need to keep arguing?
No.
No, that's how you annoy people. Okay?
Oh.
We already made our point. We're not going to keep arguing. Sometimes there's extra ones there. Okay, that happens. Okay. A lot of times you don't even have the outline. I'm actually deciding to give you the outline. So sometimes there's more, sometimes there's less, or sometimes there's more, sometimes there's just enough. Okay.
So you have to draw it sometimes.
I'm not gonna make you draw it, but in some classes or sometimes in my class will make you. Okay. So the only thing that was new was we had to do the left side on our own now. That's just doing an algebra equation now. Okay. Let's go on to number 2. Okay. What are we gonna write in our first statement? Actually, excuse me. I want you guys to try this one on your own.
Okay, cool.
Okay? I want you guys to try this one on your own, okay? When you have it or have questions, raise your hand, okay? That's the people not raising your hand so far. I don't like that, okay? Make sure we're raising your hand. Remember, when you're done or have questions, raise your hand. Okay? Very good. We'll check.
Quiet.
I'm going to Spanish too.
That's hot.
I know, right?
Hey, Sam.
Oh, no.
Now, lots of people. There you go. Okay, so whenever you have to write position, don't worry about this side. Work the problem. Okay? Yeah, it should be. Ew, my frog.
I got you.
There's no way
I just do jumping. With that
Stoner, you open up a boutique.
boutique,
Yeah.
that's for clothes. It's a salon.
I'm not good at English, alright?
So Stoner, you're gonna open up a salon.
Just give a messy bun like this has one. I could do that. Let's just do that.
What do I do wrong?
You're with
Okay,
me.
so first statement is going to be our given. 2 times x minus 9 is equal to negative 10. The reasoning behind that is what? It's given to us. Thank you, Emily. Okay? What's going to be the first step we do, or between our first and second step, what are we going to do?
You're gonna.
Distribute.
Yeah.
So once again, it's going to be helpful to solve it down here. We're going to have 2x minus 18 is equal to 10. And we said it in what we're going to do. That's going to be our reasoning. Distribute. Oh, so it's our distributive property. Oh, thank you.
Oh, rip. I think I forgot that.
Ooh.
No, I didn't.
Okay. What would we do after the after distributive? We do addition. We add 18 to both sides.
See.
2x is equal to positive 8. Oh, what tells us that we can add the same number to both sides, and that's perfectly Gucci.
Addition.
Addition property. Very good.
Are you gonna do the next one by yourself?
And then what do we do with this?
And then you divide.
Divide both sides by, and x is equal to 4. And hey, x is equal to 4, and we were told we divided on both sides, so that's our division property. Here's the thing, should we have known x was going to be equal to 4? How? It says what we're trying to prove. So if we got an x equal to 5, should that have been alarming?
Yeah.
Yeah. Okay,
I totally forgot about that.
questions on this one?
No.
Okay, here's what we're going to do, guys. Okay? We're going to take number 3, we're going to skip it.
You did it.
Nice, got extra practice. We're going to take number 4, and we're going to skip it.
I need a little more.
That's good, okay.
We're gonna skip this whole page too.
Okay. We're going to,
Only if Mr. Costas is in a good mood.
if Mr. Faust is in a good mood, then we get to skip more problems.
Then we're gonna do our homework faster.
Oh.
Oh!
Throwing all this
Alright.
stuff in there.
Yeah, let's give number 5.
Why?
Good.
It's cake, that's why.
Let's look at number 6. Did I say Why does that a skip 3 problems? I get a
You sure you don't want to skip this
Wow. I'm gonna have you guys do all like the rest of it now. I probably was going to, but I might now after that. Man, the disrespect. The disrespect. I'll tell you. Okay? I want you guys to do this number 6 on your own. When you're done, raise your hand. If you have questions, raise your hand.
Wait, come see if I did mine.
I will.
I think I did, but I was doing
Oh, shoot.
Oh, hoo, hoo.
They deal with that.
public things that-
It's a common one. Thankfully, we normally only use this one for stuff.
Yeah. But it's over here in our properties.
It still is a property, we just don't use it up very often. Very good, go check. Go. They don't have 7th-hour advanced suites.
Yeah.
I get to see you guys next hour too.
Wow, where's D?
I don't know. I just don't cover.
Are you gonna lift?
Not planning on it. I don't want to outdo you.
You and you outdo me.
Challenge flip it and just step.
Oh, yeah.
Where's the end at? It should be on
No,
the set, right?
yeah, that's correct.
The end is still on the center.
Oh, sorry.
I know, I'm so mad at you. Being so aggressive and yelling.
I guess they don't want.
Right. Gucci. Thank you. Oh, thanks, man. I like your Masons.
Why are you wearing
What are
glasses?
you doing?
Hey, don't.
Hey, we're flexible.
Oh, you need dreads in here? Not dreads, not dreads.
No.
Oh, one like that big?
No, let me hold you, no. Let me hold you straight.
You're gonna give me
Oh,
one? Thanks.
that would actually look
You gonna give me one?
Yeah, right.
What is it?
No, if you got corners.
Hold you down.
I've never seen it. I don't watch it. That's crazy.
Dude, it looks like, huh?
Can you speak from experience?
Oh, hey, I'm done. Why do you have that as your background?
You said your collar cruise over?
I would never ask you to teach me that.
What do you have that? Why?
He says it's motivation.
Alright.
Right.
Is it? What do you say? Only if it's appropriate.
Who is that?
He said we're the junk shop, yo. I'll do anything.
Who is that? Oh, okay. Who's that?
The D2 guy did that?
Reading.
Grayson.
Oh, man.
Want some candy?
Like if it, if.
No, I'm good.
Can I have some?
If
Oh,
they're
D3
on
can't
the
scholarship.
side, you have to leave the room
Huh?
all the way
D3
around.
can't give out scholarships.
Yeah, but aren't D3 schools generally?
Not full rides, they can give you half.
You can't give you athletic scholarship.
Really?
That's a
I
rip.
mean, they give you other scholarships. They can't give you athletic ones. So they give you ones. They don't call them athletics. Because they're not athletic.
Hey, have you seen that movie? Division 3?
No.
You what? You haven't seen Division 3?
Well, mine got non-athletic scholarships from about 10,
You get scholarships. They're just not athletic.
so if he's not playing
You need to
football,
watch it.
he still gets a scholarship.
Yeah, right.
You need to watch it. You have to watch it. No, not.
First step is what? are given 5n minus 42 is equal to 12n. I really hope no one gets the first step wrong on any of these, okay?
No. It's literally
Wait.
there for you.
It's literally there for you, so copy it down. Second step though, okay, well maybe. Still hope not, but I hope none of them gets anything wrong, but maybe, okay? What's gonna be our first step or our second step? Subtract 5n. So negative 42 is equal to 7n. And that was our subtraction property there, okay? Okay? Negative 42 is equal to 7n. How do you go about this now? Divide both sides by 7. Negative 6 is equal to n. So division property. Okay, and then how do we get to our final part of n equals negative 6?
Switch them.
Flip it. That's our symmetric property of equality. Now here's the thing, guys. I'm going to put an asterisk next to this. I'm going to put it in a different color even too. Okay? Because do we know that negative 6 is equal to n is the same as n equals negative 6?
Yeah.
Okay? So hopefully that should be an easy point for us. But here's the thing. I'm actually going to be perfectly okay with us leaving it at this as our answer. Okay? I'm going to be okay with us leaving this as our answer when I ask us to prove this, just because I'm going to be nice about it. Okay? So if I ask for this and you guys give me this, I'm going to be okay with that. Okay? Because sometimes just how we go through it and solve the problem, it ends up to where it's on the flip side and we don't have any more room. I don't want you guys have to add column. Okay? Because sometimes I think there are better algebra skills to do it this way than to do it on the other way. Okay? Now I don't want you flipping it and then not saying why. Okay? So you can't go from this step straight down to this step with no explanation. Okay? That would be a two-step process. Okay? You can't use two properties in the same step. Okay? But you can go from here to here and call that good. Okay? If you wanted. Does that make sense?
Yes.
Okay, we're gonna skip 7 and 8. Okay? And we're gonna go to the very back page. Okay, we're gonna talk through a couple of these. Okay? It says name, math, property. Okay? Okay. So what we're saying is, hey, if we start off with the left side, what happens to get to the right? So if k equals 3, then 3 equals k. What did we do? That was 8. That was our symmetric property. Don't cross it out though, you might reuse it, okay? We're not gonna go through all of these. We're just gonna go through a couple to make sure we kind of understand what we're doing. Okay? If 2x is equal to 14, then x equals 7. What do we do to get from here to here? We did divide both sides by 2 to get from the left to the right. Okay? Whoa. Let's cut out our blurring, okay? Number 3. 4 is equal to 4. Something's equal to itself. What is that going to be?
Addition.
G, that is our reflexive property.
How's that addition?
Oh, what's
Okay.
up, Brandon?
That's our reflexive property. It's the same thing's equal to itself, okay? Same thing is equal to itself. Hey, let's get down to number 5 here. If 10a is equal to 2b, and 2b is equal to c, then 10a is equal to c. Raise your hand if you know what that one is, okay? Raise your hand if you know what that one is, okay? If 10a is equal to 2b, 2b is equal to c, then 10a is equal to c. Braden. It's going to be I. It's our transitive property. We didn't really talk about that one much, except for our opening example. Okay. But that is our transitive property. Okay. Last one we're going to do. I want us to do number 13. I want us to try number 13. Okay. Don't learning. If given that 3x squared plus 1, okay, if x equals 5, then 3 times 5 being squared plus 1. Okay. What did we do to get to that? Why? We did do substitution, okay? We were told, hey, x equals 5, so we replaced x with 5, okay? We're able to do that according to our substitution property. Questions on that?
No.
Okay, we're going to put those away, okay?
Who's the brothers?
I do.
Oh, I have brothers.
So, on this one, guys, and on this one, guys, the first nine, okay, are like the last examples we just did there, okay? And you can cross them out after you use them. On these, you can cross them out once you use them, okay? Then, the rest of the worksheet will be like the ones we did before.
Thank goodness.
Wow. Wow.
I won't give you extra.
Here, I'll take
I'll
that.
take it.
You remember Deshaun? Rat. You're edgy. Look at, oh my god.
Hey Grace, can you tell that quiz?
Huh?
Quiz?
Yeah, probably.
I need that.
You do?
I do.
Big old rip.
Gracie,